Hello, our most valued student. My name is Confident. Welcome to our revision session. This is Engineering Science in N2, and our topic of interest today is friction. This is a continuation of the previous lesson that I did, and I call this the complete guide to friction. So if you have not managed to see the previous lesson, I'll encourage you to grab hold of that previous lesson. And I'm using previous papers for the revision. And just to start or begin our lesson, I'm going to look at this question that was written in November 2019, but I'm only focusing on one question, as I said, on one topic, which is friction. Now, if you have not subscribed to our channel, I'll encourage you to go now and subscribe to our channel, because it helps us to see that you guys are benefiting from the channel. If you're not subscribing, it's very difficult to know how many students were assisting, but by subscribing, in a way, you give us that motivation to bring more of these videos to you guys. And also remember to turn on that notification bell so that you can be notified every time we post some new videos. And also, please share the channel with others. Secondly, don't forget to leave your comment. You can leave your question, you can leave your suggestion, you can leave your input so that we can know what you guys are thinking. As you are commenting, trust me, it is a big motivation to bring some of these videos to you. So as I said, let us look at this question, which is November 2019, and I'm focusing only on friction. So remember, your information sheet is where you will find some instructions as well as some of these constants or some data information that you need whenever you are answering your paper, but we're going to come to these whenever we need them. And as I said, the question that I'm interested in is question number 6. As you can see, this is the question that has to do with friction, but they combined it. In this question paper, it was hydraulics and friction. Well, I'm interested mainly in friction, but I will, in a way, answer this question on hydraulics just in brief. I'm not going to say much on it because the main focus is friction, just for you, because it was a combination of that. Now let us look at 6.1. It's a vertical cylindrical shape container of water has a diameter of 250 millimeters and a perpendicular height of 10 meters. Now it says calculate the absolute pressure at the bottom of the container, and then this is 4 marks. Now if I can just have a new page just to look at that. So it says we have a vertical cylindrical container. So we have, in a way, if I use maybe something else different. So this is kind of a container that you have, vertical container, cylindrical, as they are saying. So now this particular container, they are telling us it has a height. Here they are saying it has a perpendicular height of 10 meters. So this is the height, which is 10 meters. And also it has a diameter of 250 millimeters. So the diameter in this case is the distance from that point to that point. Now the diameter D is 250 millimeters, which is let me write it as is, but remember, when they bring in millimeters, you need to convert to meters as the SI unit. Now the question here says calculate the what? We need to calculate the absolute pressure at the bottom of the container. So we need to find the pressure here at the bottom of the container. We need to find the pressure. Now for us to find the absolute pressure, let's go to our formula sheet so that you can see where can you find. There is a formula that deals with absolute pressure, and this is the formula that deals with absolute pressure. You can see it. Let me just mark it for you. There is the formula that is dealing with absolute pressure. So it is PAPS is equal to PATM, the atmospheric pressure, and the pressure of the material, which is the PMET. And P, also the formula for pressure, so there are two formulas there, is equal to rho GH. Rho is the density, PGH, that is the rho in a way, which is the density times gravity times height. So now if we're going to use these two formulas and say P APS is equal to P ATM plus P MET. So now, and again, I say there is another formula P, which is rho GH. So this is the formula that we're going to use, and the information that we're given in this case, we're given that their height, in this case, this is the perpendicular height that they're talking about. So now we know the atmospheric pressure. Remember, it says the pressure at the bottom. So we have the atmospheric pressure that is affecting already the pressure at the bottom, and then now the atmospheric pressure, you find it from your data. If you look at your data here, you will find that you are given the atmospheric pressure, and in this case, this is your atmospheric pressure, which is 101.3 kilopascals. So that's what we're going to use as our atmospheric pressure. So we have got P ATM, which is 101.3 kPa, it's kilopascals. As well, now we need to find our PMET, and we are going to use this formula, which is going to be P or rho GH, which is perpendicular in this case, perpendicular height. Now the density of water, again, you come to the formula, it will give you the density of water, and the density of water here, as you can see, it is 1000 kilograms per cubic meter, as you can see that. So it's 1000 kilograms per cubic meter. But now our formula for, don't forget that the atmospheric pressure here is 101.3 kilopascals, and the density is 1000 kilograms per cubic meters. So if I have that P here as 1000, it's 1000, and then times, now gravity or G, again you use G from the formula sheet. You can see acceleration due to gravity, which is 9.8. That's the one that we're going to use. So we have 9.8 there, and then times the perpendicular height is 10 meters. So if you multiply that, you will get it is 1000 times 9.8 times 10, and then it gives us 98. Let me do that again. It was 1000 times 9.8 times 10. This is 98,000. So it's 98,000. Now this is pascals, remember. So now, but our atmospheric pressure is given in kilopascals. So it's up to you whether you want to change everything to pascals or kilopascals, but the best thing is to convert everything to kilopascals. So our PMET is equal to 98,000 divided by 1,000. That will convert everything to kilopascals. So you're going to have 98,000 divided by 1,000, and you can see it is 98 kPa. So now to find the final answer, you are having, remember, absolute pressure is equal to, we say PATM, which we have here, plus P met, which we also have there. So this will be equal to 101,3 kPa plus 98 kPa. And then the answer that we're going to get there, which is 101.3 plus 98, it gives me 199.3. So we've got 199.3 kPa. So that is the answer for that absolute pressure. And the question was calculate the absolute pressure at the bottom of the container. And then the main lesson I'm actually earmarking, it is question 6.2. That was the reason mainly. Now 6.2 says a body weighing 15 kg is placed on an inclined plane with an angle of 30 degrees with the horizontal surface. The coefficient of friction between the body and the sliding surface is that. So we've got the coefficient of friction, which is our mu there. So our mu is 0.25, and then the body has a weight of that on an inclined plane. So now if we were to work on this, you need to kind of have an idea what we are referring to. So I'm going to give it a sketch. So we are saying you have an inclined plane like that. So in this inclined plane, it has got an angle, and they are saying the angle of the inclined plane is 30 degrees. You can see that part there is 30 degrees. So you have got an inclined plane of 30 degrees, and then it says a body weighing 15 kg. So if I can have my body there, it's weighing 15 kg, and then sorry about that, it's weighing 15 kg, is placed on an inclined plane with a horizontal surface. The coefficient of friction between the body and the sliding surface is that. Now before we do any calculation, for example, let me just read through the questions. Calculate the weight component perpendicular to the incline and calculate the frictional force. Now for you to always be able to answer such questions, you need to draw your space diagrams or your free body diagrams of this shape, meaning try to show all the forces that are acting on this body. Now the first things first is we have a force that is acting perpendicular to the plane, and we call this force our normal, which is our N. And we have a force that is acting downwards, which is vertically downwards, and we call that force the weight of this body. That is, the weight is always acting vertically downwards. So these are the forces. Now since this body is in a way, it will go this direction, that is where everything is sliding down. So we will have our friction that will be opposing this body, and friction acts, let me actually use a different color for friction. Friction is opposing the motion, and friction will be going in the opposite direction, and we'll call that F mu. So this is the forces acting. But now something with this diagram is the component of this weight. The weight has got two components, and that is where this particular answer, question 6.1.2, is requiring. Every time you must remember the weight has two components, and if I'm to draw the other diagram, which is the one now that is showing all the forces acting now with the weight component, so I'm just going to focus on the weight component of these forces. So we are saying where there was the weight, now you are going to have two forces, and the component of that, remember, we have the normal, which is acting this direction, and instead, okay, we have the friction, which is acting upwards. So this is our F mu. Now, instead of having the weight acting perpendicular, acting downwards, vertically downwards, we can have the component of this weight which is acting in a way perpendicular to the plane. Now, this is my plane. Just want to show you, this is my plane. So anything that is acting perpendicular to the plane, which means it is acting at 90 degrees with the plane, is the component of that weight, and it is like that. So this is the component of the weight perpendicular to the plane. As you can see, there is a 90 degrees. That's what it means. So this is my component of weight, and I will show you what is the formula for that one. And we also have a component of weight that is acting parallel to the plane. It is in this direction. So now this is weight perpendicular. So I can say weight perpendicular, and then here I can say weight parallel. But there is a formula for this weight perpendicular. If you go to your formulas, we can look at that component, and these are the formulas for that. As you can see, these are the formulas. So the one for the parallel, this is the weight parallel, and that is the weight perpendicular. So it's W cos theta, meaning if we come here, we have the weight perpendicular. It will be, in this case, our W cos theta, and the one weight parallel is equal to W sine theta. Not forgetting that our theta there is the one which is 30 degrees. So if they are asking now, says calculate the weight component perpendicular to the inclined plane, so they are looking for that part which is perpendicular. So you are going to say weight perpendicular is W cos theta. Now we know what is W again. You come to the formulas here to find W. Is there on the formula, the weight, how you calculate weight, and you can see on the formulas, the formula for weight is M times G. So that is the formula for weight. So if I come here and say where there is weight, I put M dot G cos theta. So this is how the formula becomes. Now what is the M? They told us the weight of this body is 15 kg. So our M is 15 times our G. Don't forget now, when you come back to the information sheet, the acceleration due to gravity G is 9.8. We did that on that part. It is 9.8. And cos our theta is 30 degrees. So when you simplify that, we get 15 times 9.8 cos 30. And this is 127,305 to 2 decimal places. It's 127,306 to 3 decimal places. 127,306 newtons. Let us see how we are supposed to round off. Usually they give information on the rounding off. So if I can check, okay, they didn't give us any information here on rounding off. So you can leave it to 3 decimal places, or you can leave it to 2 decimal places, which can be 127,31 newtons. So this is the weight component perpendicular to the plane. The next question says calculate the frictional force. As you can see now, calculate 6.2.2, calculate the frictional force, and it is 2 marks. Now for us to calculate the frictional force, we need the formula to be able to calculate friction, and we have this formula for friction which says mu is F mu over NR. So if I can come here and say in here and write mu is equal to friction over NR means the normal reaction. This is, in this case, our NR that I was having here. Now, remember, I'm interested in friction, so for me to be able to find friction here, I need to, in this formula, to make, what I need to do is to make F mu R the subject of the formula. So I need to multiply everything by NR, and even this side by NR. You see that? Or if you want, you can input the values first, substitute the values, and then you can simplify later. They told us that the coefficient of friction is 0.25, that is our mu. So I can come here and say 0.25 is equal to F mu over, now my NR, you can see this is the diagram that is most important I'm supposed to use. It will give me my mu R. Now, how do I use the diagram? Look at the forces. Let me use my red pen. Let's look at this particular force, because it is the one that is connecting N and mu R. You can see that I've got two arrows, one pointing up for NR and the other one pointing perpendicular to the plane for weight that is perpendicular. Remember, so the only forces that are acting, you see that we have got NR, and opposite is only weight perpendicular. Now that is what it means. It means NR is equal to weight perpendicular. That those are the forces that are opposing each other. You don't have any other force that is opposing each other. Yes, I know you want to find F mu R, but for you to find F mu R, you need to know NR, but NR is only opposed by weight perpendicular. So that is the force that you need to use, and the good thing is already you know what is weight perpendicular. You did find it there. So you can come here and say, as a side note here, to say NR is equal to weight perpendicular. So NR in this case, it is equal to 127.31 newtons. Remember that? So we'll have where there is NR over 127.31. So that is what I meant when I say now you can solve, multiply by 127.31 and also multiply by 127.31. That is how you can get rid of that fraction. So your F mu will be equal to, you have to multiply that, which is 127.31 times 0.25, and the answer there will be 31.8275, which is in two decimal places is 31.83. And remember, you always need to leave your units, and in this case it is newtons. So guys, this is how you can find or solve such questions that deals with friction. So now let us look again at the last question, as I considered this as a complete guide, and in this part I'm looking at November 2018 paper, as you can see that. So that is what I'm using. And in this paper, again, let us look at friction as the main interest. And we are looking at question 6. That is where I have got the question on friction. As you can see, question number 6. So now in question number 6 says define the coefficient of friction. So you are supposed to give that definition. The question is, how will you define such a coefficient of friction? Now, if I come back to the formulas, remember, we have this formula. Mu is F mu over NR. So if I come here and say my mu is equal to F mu over NR. Now, this is what will define or give me the definition of the coefficient of friction. You can say it is the ratio because F mu over mr, that is ratio. So it is the ratio of friction. It is the ratio of friction and the normal reaction, because nr is the normal reaction to the surface. So that's what it is. We are just describing that to say it is the ratio of the friction, or it is the ratio of the minimum, or actually we can say it depends, because there are two types of mu they didn't explain here. There is kinetic and there is there is static friction. So we can say in this case it was kinetic friction, which is the maximum ratio, the ratio of the maximum friction with normal reaction to the surface. So it's the ratio of friction, or frictional force, with the normal reaction to the surface. So that is the coefficient of friction. Remember, the definition is the formula that we are given is the ratio of friction with normal reaction. Now 6.2 says a block of wood was placed on a ramp and drawn down the ramp with a force of 60 newtons. The angle between the ramp and the horizontal is 30 degrees. The block has a mass of 40 kg. Now let me just read through the questions just to get an idea what are the questions about. Number 1, calculate the weight component parallel to the plane. Number 2, calculate the weight component perpendicular to the plane. Number 3, calculate the frictional force, as well as 6.3, state one method of reducing friction. So this question is actually similar to the previous question. I need to sketch this graph to have an idea what I'm talking about. So let us look at it. It says a block of wood was placed on a ramp and drawn down, meaning you are pulling it down. To draw it down means there is a force going down with a force of 60 newtons. So let us draw that. So if I can have a diagram to say you have like a ramp here, and the angle that didn't change, they say there is 30 degrees. So you have a body that is drawn down, so something is pulling this thing down with a force. And now while it is being pulled down with a force, let me just do this just in the center. While it is being pulled down with a force, they say the force, it is drawn down with a force of 60 newtons. So in here we have 60 newtons, but you know that there is always something that is opposing that force, and that force that is opposing the motion going downwards is friction. Remember, friction always opposes movement. So there is friction that is going upwards in this case. So you'll always have friction opposing the motion of the body, and we call that F mu. And then there are always forces that are acting perpendicular and parallel to the plane. So there is always the normal force that is acting perpendicular to the plane, like that. It's always the normal and our normal reaction force. And then we have the component of weight, and now this component of weight is always acting vertically downwards, like that. All right, so we have got that force that is always acting vertically downwards, and we call it our weight. But as I said, this diagram has got two components of this force that is hidden, and this particular weight, which is hidden, has got two components. So this weight has two components of forces, and I'm going to draw them. There is the perpendicular component. See that component there it has that component that is hidden, and then there is the parallel component which you always must draw, but I think it's best if I can use straight lines. So it has got this force, I make it long, and the weight also has got another force, which is this force. So these are the forces that I want you to always remember. So we call this force that is perpendicular, it's always W cos theta, if you still remember from the formulas, and one on the plane is W sine theta. We call this the weight parallel to the plane, and we call this the weight perpendicular to the plane. So now that is what actually this question 6.2.1 is requesting. It says calculate the weight component parallel to the plane. You see, when they're saying parallel, we come here and we look at this part. That is what is parallel to the plane. So if you look at 6.1.1 and we're looking at weight parallel, is simple, W sine theta, and we know what is W. Remember, we did establish that W was M times G. If you still remember, we had that formula here to say M times G. So if I have that, it will be M times G times sine theta, and we need to find the mass of that object. They said it was 40 kg. The block has a mass of 40 kg. I think you can see from this part, there is the mass. So I will have 40, and G is 9,8, and times sine 30. Then it gives us, in a way, the weight parallel, which is 40 times 9.8 times sine 30. So that is how you do, it's how you resolve your forces, which is 196 newtons. Are you getting that? So that was the first part. And then 6.2.2, they say the weight component perpendicular to the plane. Are you seeing that? So in here, they were now looking for this part. This is the perpendicular to the plane they are looking for. So you're going to have now your weight perpendicular. Same thing. Remember, W is mass times G cos 30, which is equal to, we say the mass was 40 times 9,8 cos 30, which is equal to, now if you use a calculator there, which is 40 times 9.8 cos 30, it gives us 339.48. So we've got 339.48. Remember, always leave your answer with the right units. Your answer must be in newtons. So we have now answered the first two questions, 6.2.1, the weight component parallel and the weight component perpendicular. Now the next 6.2.3 says calculate the frictional force. That's what they're asking now. We need to find frictional force, which is our F mu. Now again, our diagram is always the answer. If you do your diagram right, you'll never get it wrong. Now look at this diagram. If you look where friction is, look at the force for friction. So which means we're now looking parallel to the plane, and our forces that are parallel to the plane, these are our forces that we must focus on. Whenever we are dealing with parallel to the, F mu, we are looking at where it is pointing, is going up the plane, and we cannot now ignore forces that are opposing that F mu. You can see that now if we take up as positive, which means we will have F mu, which is positive going up, is equal to the forces that are going down, which is W sine theta, or actually I must say FW parallel, as you can see that one, plus there is 60 newtons, which is our F applied, which we can now say 60 newtons is the force that was applied. Remember, it is being thrown down, that's what they said. So now our W parallel, they say it is 196. We have it there already, so it's 196 plus the F that were given was the applied force in which this object was being pulled down is 60. So if you add that, it will now give us the friction, which is 196 plus 60, and then gives us 256 in this case. So our frictional force is 256 newtons in this case. So that is how we use the same diagram. So if you plot your diagram properly, when you do your free body diagram or your space diagram, you need to show all the forces that are acting, and it's either you are looking perpendicular to the plane or you are looking parallel to the plane. When you're looking parallel to the plane, just oppose, the upward force must be equal to the downward forces. If you're looking perpendicular to the plane, the upward force again must be equal to the downward forces. So in a way, you can see that if we're looking perpendicular to the plane, we were going to focus on this. This is perpendicular to the plane. So if we think NR is equal to W perpendicular, and then parallel to the plane, it is what we got like that. When you can do that, you are good to go, and your answer easily comes out easy. Now let us look at the last question, 6.3. It says state one method of reducing friction. Now I think we have used this even in everyday life. How can you reduce friction? There are many ways of reducing friction. You can use oiling or lubrication. That can reduce friction. What can you use? You can use rollers that can reduce friction. Anything that you think can reduce friction, what can you use also? You can use oiling. Sometimes they use greasing, and you can use bearings. Anything that can reduce friction. This question is just an open question, because what they are looking for is anything here that can reduce friction. So even you can use a smooth surface. Remember, a rough surface has got friction. You can smoothen the surface, also it can reduce friction. So it's an open question that they can give you marks for that. I hope this was of benefit to you guys. Remember to subscribe again to our channel so that we can always notify you every time we are posting some new videos. Thank you.